In this problem, we're looking to find the probability of choosing a point in the shaded region. So the probability of shaded region is going to equal the shaded portion, which is the square minus the circle, over the entire set of areas, square and circle combined, which is just the outer shape square. So here really what we're looking to do is basically take the area of a square minus the area of the circle, all divided by the area of the square. Okay, so, and looking at this, if we know that the diagonal of this square is 22.25 square root 2, based on the patterns of an isosceles right triangle, we have x, x, x root 2. So that tells us that our side lengths here are going to be simply the 22.25. It fits right into that pattern. Here is the x value. So what we can do with our calculations is we can plug this 22.25 into our s value. Okay, and when we do, we can also look to see the radius of the circle is simply going to be 1/2 of this whole side length. So the radius will be 1/2 of x, where x is 22.25. So if we took 22.25 and divide it in half, we get this to be 11.125. And so here's our calculated value. If we go ahead and type that in, this squared minus pi times 11.125 squared. Calculate that, and then divide by 22.25 squared. And we get our probability 0.2146. To 3 decimals would round up to 0.215. We could also solve this problem by finding the probability of the unshaded region. It's a little bit easier calculation, because the unshaded is just the circle divided by the whole thing, the square. So if you took pi r squared divided by s squared, plugged in these same numbers. So if we plugged in an 11.125 squared and then the 22.25 squared, what this would do is it would give us the probability of the unshaded region. So if we took that calculation here, pi times 11.125 squared, and we divided by 22.25 squared, we get our value to be about 0.785. And if that is the probability of the unshaded, the shaded and unshaded probabilities have to equal 1. So if we just took 1 minus the shaded, that's going to give us the probability of the shaded region. So if we just took 1 minus this number, it would confirm the same thing that we got up here. 0.215 would be our solution. So you can do it either way.